In lesson 1.3, as you can tell by our title, we're dealing with rate of change and slope. Okay, and I want to differentiate with this lesson the idea of an average rate of change versus the slope, which indicates a constant rate of change. All right, in our examples, we have situations where there is an average rate of change in one quantity relative to another, but when that change is a constant number, then that's when we deal with the slope of a line. We're dealing with a linear function. So that's just to kind of set up today's lesson. Let's jump into an example, a real-world example. We're told that in the year 2004, there were 56,000 plus students applied to UCLA. 2 years later, there's over 60,000 students applied. Our goal, our directions are to find the rate of change in the number of students applying for admission. So let's go ahead and identify what is a definition of rate of change. Well, it's a ratio. And when you see the word ratio, you probably think the word fraction. That compares how much one quantity changes on average relative to the change in another quantity. So in our problem, the number of students is changing, that's one quantity, over a certain number of years. That's the other quantity. So that leads us to a formula for determining the rate of change. And so the rate of change, as long as y represents the dependent variable quantity and x represents the independent variable, then this is the formula that we're going to use. We're going to note the change in the y values, and we're going to divide that by the change in the x values. Now I put this in this form because going forward in higher level math classes, you're going to see it written as delta y over delta x. The Greek letter delta literally means change, or the change in a quantity. So instead of seeing it spelled out, you're going to see the word or the symbol, Greek letter delta. So the question normally arises when I'm doing a real-life application problem like this. Yeah, I know to find the difference or the change in the y values, and I know to divide that by the change in the x values, but in reading through the problem and seeing all these various numbers, how do I know which values represent y's and which one represent x's? So I want to cover that with you in just a moment as we talk through this problem. But let's go ahead and get our formula. The way we discover the change in the y's, or delta y, is we take the two y's, we'll call them y2 and y1, and we'll subtract. It's the difference between the two y values divided by the difference between the two x values. Now in Algebra 1, you were taught that that is the slope formula, and it certainly is. But I just want you to understand that in real life, not every situation involving the change in one quantity relative to another is linear. And so we wouldn't call it slope per se if it's not a linear change. We would say there's an average rate of change. Okay? So just want to make sure we draw that distinction. And so here's our formula. So once again, I'm going to pose the question, what number do I plug in for y2 and what number do I plug in for y1? Well, what numbers in this problem represent y values, variables? Okay, well here's something that you might, if that's something that you struggle with, and from one problem to the next, it may be worded in a way that could be a little confusing. Here's something that always works. I offer it as a suggestion. You can always label or think of the y coordinates, because technically we have two ordered pairs in this problem. The y coordinates will correspond to the quantity that we are asked to find in the problem. And if you notice, this last sentence indicates that we're supposed to find the rate of change in the number of students from given year period, a given year time frame, 2004 to 2006. So we're given a year frame, time frame. What's unknown that we're supposed to find is the rate of change in the number of students. So whatever it is in the problem that is unknown that we are asked to determine, in this case number of students, that will be always the y in our formula. So I'm just going to put a little y above each one of those numbers representing a student enrollment. That means the given quantity, in this case years, will be labeled as x. Maybe you don't need that. Some people do have a little trouble identifying, and they end up switching, flipping this over, and their slope, of course, is inverted. So just wanted to throw that out as a suggestion if that's something that you may struggle with. So you can think of this as the ordered pair 2004, 56,878. And this would be the order pair 2006, 60,291. So now we've got our x's and y's straight. We're ready to do the calculation. So I'm going to take, it doesn't really matter which way you go, I'm going to treat this as y2, 56,878. And I'm going to subtract from that the other y, 60,291. Okay, so since I started with this as my y2, then this has to be x2, of course. So 2004 minus 2006. And we do the subtraction of the numerator and the denominator, and then divide. And then you end up with the number rounded. It's 1707, 1707. In decimal form, it was 1706.5, but since we're dealing with a number of students, we're going to round to the nearest student. Now, in word problems like this, it's always a great idea to represent your answer in context. Let's not, instead of just saying 1707, let's place this in a sentence that provides some context to our answer. And there's a couple of different ways to phrase it. On average, student enrollment increased. And that's important because obviously we went from 56 to 60, so we need to show the direction of how the quantity is going. Student enrollment increased by 1,707 during this time period. Oh, 1,707 per year. Sorry about that. Left that off. Over this period. Something to that effect. I need for you to tell me in some wording, some sentence to make our answer make sense for the given problem. All right, so that takes care of this example. You may have some in your homework that look like this. And so let's go ahead, we touched on this earlier, but let's just go ahead and finish this slide. When the rate of change for a set of data is a constant, the rate of change is known as the slope. Constant rate of change is the slope. And the data itself represents a linear function. It will be the graph of a line. Very good. Okay. My second example, you're going to be doing some problems like this where instead of given a scenario, you're just given an equation and you're asked to determine the rate of change. So rate of change can be found by looking at the slope-intercept form of the equation and then taking the coefficient of x, of course, that stands for the slope. So really all we have to do in these problems is solve them for y, and we'll be able to see what the slope is. So I'm going to go ahead and divide by 4. Y equals 3/4 x minus 7/4. And so my answer here for letter A, of course, would be 3/4. This one's going to involve a little bit more work. I'm just going to subtract 5/2 x from both sides. And then I'm going to multiply by the reciprocal of negative 3/4 on both sides, which is negative 4/3. Make a negative sign. Alright, and so that's going to make it solve for y. And when I multiply negative 5/2 times negative 4/3, I get 20 over 6, which is 10 over 3x. And then, of course, I need to go ahead and multiply this, and this will be negative 36 over 3, which is negative 12. But really, the important part of this is the coefficient of x. And so the slope for this particular equation will be 10/3. Of course, you also had the option here of clearing out denominators first by multiplying both sides of the equation by 4. And if you chose to do that, or if you thought about doing that, you would certainly be okay in following that procedure. Okay, I just have one more example, and I thought I'd show you one of these, like these 4 problems that you will do on the assignment. So we're trying to find this missing y coordinate in this problem. It's called r, so that the line that passes through each pair of points has the given slope. So we can go ahead and set up our rate of change or slope formula. So we'll do y2 minus y1, which in this case is r, divided by x2 minus x1, and we know that that's going to equal 2/3. All right, so 4 minus 7 is negative 3, so we can basically multiply by negative 3 on both sides to clear that denominator. And multiplying by negative 3 gives us negative 2. Adding 2 to both sides. Adding 2 to both sides, negative r equals 0, so that means r is 0. So in this case, the part of the ordered pair that we're looking for is 0. So I just wanted to give you a taste of how those work so that when you get to those problems, you'll understand. All right, so I think that does it for this assignment. These are the problems that you're going to do. And so if you have any questions, let me know.